Hello everybody, today we're going to take a look at the idea of inverse functions and how to find an inverse. For this you're going to need your notes, a pen or pencil, some graph paper or obviously your graph paper notebook, and a calculator would also be handy as you're going to be calculating and making some tables, and sometimes that goes a little bit quicker if you have a calculating device. So the first thing we need to write down is the definition of inverse. What does it mean to be an inverse, especially an inverse function? So basically the idea of the inverse will interchange the x and y values of a set of points, an equation, or whatever. So the inverse is going to change the x and y around. That's what that means. So the x and y will switch places. To make sense of what this means, let's take a look at an example you don't need to write down. The basic idea is we can find an inverse by switching the x and y around. So you see I have a set of points down here. Oops, you can't really see the x and the y right there. I'll move this up. There we go, x and y. I see the x values, I see the y values. If I were to graph those, 4, -8, they would make this arrow right here. The set of points you see are the ones that were connected to make that arrow. So if I wanted to find an inverse to see what the inverse of that arrow would look like, basically what I do is I flip the x and y's around for each point. So what was an x now becomes a y, and what was a y now becomes an x. So if I was going to take this point right here, I'd make it -8, 4 now. I switch them around. -5, 4, -5, 3, -3, 5. -5, 7, -5, 6, and -8, 6. And then if I go ahead and graph all of those, -8, 4, -5, 4, and -5, 3, and -3, 5, and then -5, 7, and -5, 6, and -8, 6. You can see the arrow up there, okay? Basically what happens is an inverse is a reflection, just like you talked about in geometry. If I were to flip that arrow over that line right there, the line y equals x, that's what he would look like. He would flip diagonally over that line, or if I was going to fold right on that line, this is the location of where he would land. He's still an arrow, but now he's in a new location, turned a little bit it looks like, okay, because of that reflection line. So when we think about x's and y's, think about that inverse relationship, how x and y switch around on an inverse, and that the graph should still have the same general shape, but it might be pointing a new direction based on that reflection line, okay? So let's take a look at graphing a function and its inverse. This is the first example you need to get in your notes. So I have this equation here, this function here, and I need to make a table of values for this function. Now, you should choose maybe negatives, positives, a little bit of both would be good. And then we go ahead and take these values and plug them in right there to calculate the y. So this y value would be -2 cubed plus 4. And then we type it in just as we see it there, guys, with the parentheses and all, so we can find out that value that we need, or that value that is that y value, okay? So I'm going to use my calculator just like you would use. And we'd have some parentheses, -2 cubed. And if you want to calculate in your head, you can do that too. Remember, -2 cubed would be -8. Put a negative sign on it, would be +8. Adding 4 would make 12. Okay, do the next one then. We'll do the same thing. We'll type in -1. Sorry, I'm having calculator problems here. And that's going to be a 5 this time. And then we'll type in with a 0. And that's going to be 4 this time. And then we'll do the 1. 1 cubed is 1. Put a negative sign on it. Makes a 3. And then we'll do the 2. So each time we're changing the x value. leaving the parentheses where they are. We're changing that x value in there to help us figure out what the y value is. And then we can go ahead and make a picture of this function here. So negative 2 up 12 would be like way off the graph over here. Negative 1, 5, 0, 4, 1, 3, 2, negative 4. So this is the look that we have for this function. Okay, so this one is the original. I'm going to put an O there for my original. Okay, here's my original. And now when I need to find the inverse, because it says graph the function and its inverse. Now, if you made a good table for the original, which we did, the inverse table is pretty simple because we just found out you just switch x and y. So I'd plot 12, negative 2, 5, negative 1, 4, 0, 3, 1, and negative 4, 2. And when I make a picture of that, it's going to graph the inverse for me. So I got to go over 12, down 2. That's going to be off my graph a little bit too right here. Over 5, down 1. Over 4, 0. 3, 1. And negative 4, 2. Check that out. It's like our wave, okay? The inverse has the same general shape, but he's kind of turned in a different direction. So this one would be my inverse, and I'll label him with an I so you know which one's which. So we've graphed the original using a table, and we graphed the inverse by switching the x's and y's in the table. Okay? Is the inverse that we graphed or that we made still a function? Remember, functions will pass the vertical line test. So if you grabbed your pencil and you made your pencil go vertically across the page this way, would it hit the blue one in more than one place at a time? The answer is no, so it passes the vertical line test. Because it passes the vertical line test, we would say yes, the inverse is in fact a function. Okay, let's take a look at a second example here. Same idea. Okay, same idea. We're going to go ahead in there and make a table and then switch our table around to find the inverse. Plain and simple. Okay, so let's make a table with some negative values, positive values, and we'll plug them in. To plug in here, I'd have negative 2, parenthesis where the x goes. This would be what I calculate. Okay, and I'd start on the inside if I was doing it in my head. This becomes 4. 4 times negative 2 is negative 8. Plus 1 makes negative 7. And then if I calculate the next one, it'd be negative 2. Change that negative 2 to a negative 1. This becomes 1 times negative 2 is negative 2. Plus 1 makes negative 1. We plug in 0, we would get 1. We plugged in 1, we would get negative 1 again. And if we plugged in a 2 again, showing you how you type that in, okay, then we once again would get our negative 7. So if we graphed this, we'd have negative 2, negative 7, negative 1, negative 1, 1, 0, 1, negative 1, and 2, negative 7. Hey, look at that parabola. Did we see that that one was going to be a parabola? I hope you did, because it has a squared in it. Everything with a squared graphs into a parabola. So now if we take those points and we wanted to find the inverse to graph the function and its inverse, to find an inverse, pretty simple. Switch the x and y's around. This is now my inverse table. So the red one is my original. I'll label that with an O. Now I'll graph in blue my inverse, negative 7, negative 2, negative 1, negative 1, 1, 0, negative 1, 1, and negative 7 up to, look at that. Still the same shape, little bit of a turn there. So this becomes my inverse. Is the inverse a function now? We made the inverse in blue. If I drag my vertical line across that, is it a function? Not anymore. Okay, it fails the vertical line test. There are repeating x values in my table, so it's not a function anymore since I switched the x and y's around, okay? So the idea of us being able to graph a function and its original by switching x's and y's is pretty important. Can I find the inverse equation or the inverse function if I'm given a function? So rather than make a graph and try to find the inverse graph, can I find the inverse equation? And the answer is yes, using what you know about an inverse. Basically, again, an inverse, they switch the x and the y around. So what was a y now becomes an x, and what was an x now becomes a y. So this equation would turn into this. Then what we would need to do is solve for the y. The y is always alone when we go to graph things or when we're working with functions. So I need to get this y by himself after I switch the x and y around. So I'll go ahead and subtract 5. I'd have x minus 5 equals 3y. And then I divide by 3 both sides. Y equals x minus 5 divided by 3. Now because this y could be confused with our original y, this was the original, there's a symbol for inverse. It's the -1 power, it looks like, okay? That means inverse. So basically, when you want to say, hey, I found the inverse equation, we would use y to the -1. Okay, that's the symbol for inverse. So let's look at example 2 here. Same idea. Let's switch the x and y around. So the equation becomes x equals 4y minus 5 over 3. And then we have to solve for the y. To do that, I'm going to multiply by 3 first. I'd have 4y minus 5 equals 3x. Then I would add the 5. I'd have 3x plus 5 makes 4y. And last but not least, I'd divide by the 4. So y equals 3x plus 5 all divided by 4. And again, I throw that little inverse sign on him to make sure that people know that's the inverse of the original function I was given. That's their relationship. 2 more examples and we're done. So what if we have some higher powers in there, like a cube or a squared? Let's work this out. Same idea though, inverse switches x and y. So this becomes x equals 3y to the 3rd power plus 5. To solve for the y, I would subtract 5, 3y to the 3rd power equals x minus 5. Get rid of the 3 in front of the y. Let's go like this. Y to the 3rd power is x minus 5 over 3. Now I have a cubed on the y, and I still need to undo that so that the y is alone. The inverse of cubing something is cube rooting. So I will cube root both sides. Then I'd have y inverse, okay, don't forget that symbol, would be the cube root of x minus 5 divided by 3. And number 4, let's do the same thing. Switch the x and the y. And we'll go ahead and solve for y. Subtracting 1, x minus 1 equals 2y squared. We'll divide by the 2 that's in front to try to get the y alone. I'd end up with y squared equals x minus 1 over 2. And then last but not least, the inverse of squaring is square rooting. Y, inverse symbol. And we got to be careful on this. We just put a square root in here, right? Anytime you square root something, what did we have to remember? Do you remember? It was this little symbol that we had to put? That's right, plus or minus. Right there. Plus or minus square root of x minus 1 divided by 2. Okay? When you square root, 4th root, 6th root, anytime you have an even root you have to take, that plus or minus is something that we need to make sure that we have, because 2 negative numbers can multiply together to make a positive, and 2 positive numbers can multiply to make a positive. So we have this idea of having 2 answers when we take things like the square root of 49 is both positive 7 and negative 7, that sort of thing, okay? So remember those plus or minuses when you take an even root. So we've looked at how to find an inverse on a graph, and now to find an inverse when you don't have a graph. The idea of inverse, make sure you switch that x and y around. If you want to put this in your notes, it'd be a great summary to put in your notes, okay? How to find an inverse, switch the x and y, solve it for y. How to graph an inverse, switch the x and y in each point. And how to tell if it's a function? Make sure it passes the vertical line test. Make sure those x's are not repeating. Thank you for taking good notes today.